When we say AI agent, we often mix very different systems into one bucket. A chatbot that summarizes emails is useful, yes, but an agent that researches competitors, drafts strategy, and schedules a meeting is operating at a totally different level. In this video, let's build a clear mental model for AI agent autonomy, step by step, and test our understanding with quick quizzes along the way. The article begins with a simple but powerful contrast. One system summarizes emails. Another takes a broad business goal, gathers data, reasons across sources, creates a strategy draft, and even schedules a meeting. Both may be called AI agents, but clearly they are not the same. That is exactly why autonomy matters. If we do not define levels properly, it becomes hard to build, evaluate, govern, and trust these systems. A classic definition from AI says, an agent is something that perceives its environment through sensors and acts on that environment through actuators. Even a thermostat fits this definition in a simple way. For modern AI systems, the important idea is this: an agent is not just answering questions. It is sensing, deciding, and doing something in service of a goal. A modern AI agent can be understood through 4 building blocks. First is perception, meaning the inputs it receives from the world. Second is the reasoning engine, often an LLM, which plans, breaks tasks into steps, and handles decisions. Third is action, where the agent uses tools to actually do something. And fourth is the goal or objective, which gives direction to everything else. Without all 4, agency is incomplete. Now let us look at this in a simple table format.
3 ways to classify AI agents.
The article groups emerging AI autonomy frameworks into 3 main lenses. Here is the main structure of the article in one view. Emerging AI agent frameworks usually fall into 3 categories. Capability-focused frameworks ask what the system can technically do. Interaction-focused frameworks ask how the human and agent share control. And context-focused thinking asks, under what task and environmental conditions, the agent can operate safely and effectively. This 3-lens view helps us avoid reducing autonomy to just one number. This distinction is very important. A standard chatbot usually perceives your prompt and returns an answer. Helpful? Yes, but limited. A true agent has a broader objective and can use external tools to move toward that objective. That is why the article says an agent has agency. It can act independently and dynamically, more like an accountant managing finances than a calculator solving one equation at a time. Now that we've covered agent basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. Which element gives an AI agent its overall direction? The correct answer is goal or objective. The goal is the why behind the system. It turns tools and reasoning into purposeful action. Question 2. According to the article, an agent without action is mainly like what? The correct answer is an oracle. The article says without the ability to act, an agent can only provide information like an oracle. Question 3. What most clearly separates a true agent from a typical chatbot? The correct answer is goal-driven tool use. The key difference is that agents work toward goals and use tools to take action, not just answer prompts. Now comes a very practical insight from the article. We do not need to invent everything from zero. Driving, aviation, and robotics have already spent decades figuring out how to classify autonomy. Their common challenge was simple. How do we describe the gradual handover of responsibility from human to machine in a shared language everyone can understand? The automotive world gives us the well-known SAE levels, from level 0 to level 5. What makes this framework strong is not just technical detail. It asks 2 practical questions. Who is handling the dynamic driving task, like steering and braking? And under what operational design domain, meaning under which conditions is the system expected to work? For AI agents, this teaches us that autonomy is really about responsibility under defined conditions. Aviation gives a more granular model with 10 levels of automation. This is especially useful for systems where humans and machines collaborate closely. For example, A system may narrow options, suggest one action, execute after approval, or even act unless the human vetoes it in time. This maps beautifully to many AI tools today, where the system behaves more like a co-pilot than a fully independent operator. Now that we've covered autonomy models, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. In the SAE driving framework, what is the operational design domain about? The correct answer is the conditions where it works. ODD refers to the specific conditions under which the automated system is designed to operate. Question 2. Why is the aviation model especially useful for AI agents today? The correct answer is it captures nuanced collaboration. The aviation framework is valuable because it describes shared control, approval, veto windows, and co-pilot style interaction. Question 3. Which category asks the question, how do we work together? The correct answer is interaction-focused. Interaction-focused frameworks define autonomy by the relationship between the human and the agent. Robotics and unmanned systems add one more critical idea: context. The ALFUS framework looks at autonomy across 3 axes: human independence, mission complexity, and environmental complexity. This is a big reminder for AI agents. An agent doing a simple task in a neat, predictable environment is not the same as an agent handling a messy, open-ended task across the open internet. Same supervision level, but very different real autonomy. The first major category for AI-specific frameworks is capability-focused. These are useful for developers because they map autonomy to architecture and code patterns. The Hugging Face model is a nice example. It starts with a simple processor that has no effect on program flow, then moves to a router, then tool calling, then a multi-step agent controlling the loop, and finally a fully autonomous agent that can even generate and execute new code. Very concrete, very engineering-oriented. The second category is interaction-focused. Here, the question is not mainly what the agent can do internally, but how control is shared with the user. One example runs from user as operator, where the human directs actions, to user as approver, where the agent proposes and waits for yes or no, and finally to user as observer, where the agent acts with broad autonomy and reports back. This lens is very intuitive because it directly connects to trust, oversight, and accountability. Now that we've covered AI frameworks, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which framework dimension reminds us that autonomy depends on task difficulty and environment stability? The correct answer is context. The robotics-inspired context view looks at mission complexity, environmental complexity, and human independence. Question 2. In the Hugging Face style capability ladder, what happens at the multi-step agent stage? The correct answer is the AI controls the iteration loop. At the multi-step stage, the AI decides which tool to use, when to use it, and whether to continue. Question 3. In an interaction-focused model, what does user as approver mean? The correct answer is the agent proposes and waits for approval. This level places the human in a yes or no oversight role before execution proceeds. If you are building, buying, or governing AI agents, this framework helps you ask better questions. What can the agent do? How do humans stay in control? And in what conditions can it be trusted? That clarity is what turns AI from hype into something practical and safe. See you in the next lesson.